Hey guys, and welcome back to a new video. In this video, I will go through all 11 types of classes we have in Kotlin because I know how confusing that can be. I'll keep myself short, give you the relevant information, and cut the rest. And on PL Coding, winter sale is online, 25% discount on all courses and bundles. Link is below. Now we got that out of the way, and we can get started with the video. I'm here in IntelliJ because here we can showcase these Kotlin-related language features a bit better. So I will quickly create the main function, and we can simply get started with the very first type of class, and that is really just a normal class in Kotlin. So let's, for example, create a class called session storage or so. So a class that stores an active session somewhere in, I don't know, maybe a file, for example. So we might pass a file in the constructor. And then this type of class could contain member functions, for example, save. We might want to save a certain value, a string or so in that file. This class might contain some kind of private variables, some public variables, I don't know, a counter, for example. Doesn't make sense in this case, but I think you get the idea. So when should you use a normal class in Kotlin? Normal class is a class that really does not have any keywords before this class keyword. A normal class makes sense if at least one of two scenarios applies. Scenario number one is your class has a constructor, like we have here. Scenario number two is that your class has internal state. Internal state sounds complex. In the end, it just means the class has certain member variables that could change over time, that are vars, or maybe a mutable list data structure, for example. So something that can change. Some variables that might make one instance of this class unique from another. Because if these things are true, that means we could just create unique, independent instances of this class, which is exactly the whole idea behind classes in object-oriented programming. So the class is the blueprint of what we want to build, and an instance is one specific instance of having that built. So one specific session storage that might write something to file A, and we might have another instance of session storage which might write something to file B. If there is such a scenario where these two instances might be relevant in your code, which there is if it has a constructor, because then each instance of this class has its own combination of other classes, of other values being passed to it, then it makes sense to use a normal class. And an important addition is that this type of class is not a pure value holder class. So it's not just meant to bundle data, but it contains actual functionality. It refers to more complex data types beyond primitives and simple lists or so, like here a file, for example. Because if that would be the case, we would stick to another type of class, who I will get to in a moment. Maybe just quickly a very important thing about classes, that is if we create one session storage 1, we create the instance just by invoking the constructor. We pass some kind of file, I don't know, hello.txt, for example. We create another session storage that is now its own instance. Here we make it world.txt. Then if we actually compare those class instances, so we check if session storage 1 is actually the same as session storage 2, then this prints false. If we now actually take this file here, extract this into a variable, and pass the exact same file to both these instances, and we rerun the program, it still prints false. So this is a very important thing to understand, that by default, if we compare two instances of a normal class in Kotlin, they are compared based on so-called reference. They are not compared based on the contents, based on the specific type of file we passed here, but based on reference. So what is checked here is if this instance is actually the same instance in memory than this one. But since we have two individual instances by invoking the constructor twice here, this will print false. If we would set session storage 1 to session storage, session storage 2 to session storage 1, and then compare this, you will see this time it will print true because this instance is the same one as this one. And that leads us to the next type of class, which are data classes. So we have a data class, and as the name says, a data class's purpose is to save some sort of data. And with save some kind of data, I don't mean what the session storage did to save something in a file, but a data class has really the purpose to take simple primitives, maybe a list, or maybe a string, and just bundle them to some kind of unified data structure that makes sense in some way. Simple example, we have a person class, and a person consists of a name. It might consist of a birth date, which is also a string, might contain of an email address, for example. So the moment you have lots of primitive data types and strings and like lists, and you want to bundle these to some kind of concepts we know from the real world, like what a person is, but this class does not really need access to any more complex types of objects, like a file, for example, that's definitely not a primitive. Then use a data class in Kotlin, because very often these data classes don't even need functionality. If you need that, you could of course add this. For example, a variable to get the current age as an integer, you would override the getter, and then here would have some logic that takes this birth date as a string, maybe parses that, and then calculates the actual age of that person. So this is completely valid to have functionality like that in a data class, but data classes in Kotlin should not interact maybe with a file, with a remote API, with a database, with some kind of system services or so. So if there is such real functionality where communication kind of leaves the program, then the data class is usually not what you need. Then you need a normal class. Because the reason is, and the special thing about data classes that compares them and distinguishes them from normal classes is that by default, the Kotlin compiler will override two very important functions, actually three very important functions. On the one hand, the equals function, the hashcode function, and the toString function. Because you'll notice something very interesting, that if we print our session storage 1, so not the check anymore, but just the session storage 1, then it will print something very arbitrary, so the class name and some kind of address in memory. That's not really understandable for us. If we now have an instance of our person, so we just create this the same way. We give it a name, we give it a birth date, I don't know, something like this, and an email. Well, it doesn't matter what kind of data we pass here, test@test.com. And if we then print the person instance as well, take a look here in logcat, then right now we also see this kind of a weird memory thing. But if we get rid of this toString override here again and rerun this, then you will see the default behavior is that it will print the class's contents in human readable form. And the other interesting thing about data classes is, if you also get rid of the other overrides here, if we now create another person, so we have again person 1, person 2, like here, and we then compare those persons that have the same type of data, same birth date, same name, same email, and we now check person 1, is that actually the same as person 2? And we rerun this, then we will see this prints true, because now, since we have a data class, these instances are now compared based on contents. So instead of checking if this is the same instance as this one, what the equals function will do, that is by default implemented for data classes, at least in a different way than for normal classes, it will compare each field. So is the name the same as this name? Is the birthday the same as this one? And the email the same as this one? And that's also why it's discouraged to extend data classes with more complex types of classes, because the moment you have a normal class as an instance or as a part of your data class, and you then compare this normal class is again compared by reference. Since data classes, when being compared, will really just invoke the double equals operator here for every single field individually. And if for normal classes, the double equals operator means they are compared based on reference, and that will also be the case when being compared in a normal data class instance. So keep that in mind. If you need to bundle related data in Kotlin, a data class is usually what you want. An additional quite helpful function that a data class adds is the copy function. So if you actually need to take one instance and create a copy out of that, so person1.copy, that is a function that is generated by the compiler. And here we can now create an exact identical copy of it as a separate instance in our code, but we can change specific fields. For example, the name, and leaving the remaining fields unchanged for this specific copy. If we rerun this now, then we will also see that the check is actually now false because we have a different name. Let's get to the next type of class, and that's actually a singleton. And in Kotlin, we model this as an object. So we have an object called dateutil, for example, that just serves as the single instance that lives across the lifetime of our application, of our program, and, for example, gives us access to certain functions. So we could have a function in this dateutil class to format a date. We pass in the date maybe as its own datetime, and we get back a string that would represent the formatted date. And this is now an object, so a singleton. We can't create instances of this class because by definition, there will only be a single instance in our code. So if we want to invoke this format function, we would simply go ahead and say dateutil dot format, and we pass in our date, and we would get back the format date. So invoking the constructor here does not work anymore because we can't create individual instances of this object, since by making it an object, we say only one instance of this is needed. Okay, I think that's clear. Let's just pass in a parameter here so it doesn't complain. If there is a data class, then That means in Kotlin, there's also a data object. So now we just have a normal object, like a normal class. But what we can do is we can make a data object, which, let's call it dateutil2. We could have the same implementation in here. Just paste this here, and it will work exactly the same way as before. So instead of dateutil, we could also say dateutil2, and it would work exactly the same way. So what's the difference between normal objects in Kotlin and data objects? Well, data objects have very similar advantages or very similar behavior as a data class has compared to a normal class in Kotlin. Mostly it is that these classes are being printed again in a little bit nicer way. So if we print an object in Kotlin and we say dateutil1 and dateutil2, and we then run this code again, we see, okay, the dateutil1 has a similar printing style as normal class instances in Kotlin with a memory address, but the second one really prints the natural kind of class name or object name as we read it, as we would probably want to see it in our console. However, there is a special scenario where we also want to have this same behavior as from normal data classes in data objects, because under some circumstances it can happen that there are actually two instances of an object in Kotlin that are actually being active in memory. For example, if you receive a certain JSON response, especially in Android-specific environments, it's often implemented the way that these JSON responses are then being automatically parsed to some kind of class instance. But this class instance could also be an object in certain cases. And if such class instances are then created with this mechanism called reflection, which JSON parsing libraries often make use of, then it can be that there are actually two such instances. And if these two such instances would then be compared with a normal equals operator, then the data object would again be compared based on the contents of that class, while normal objects would be compared on reference, and would in that case possibly return false even though it shouldn't. So rule of thumb is if your object is just used to bundle some utility functions here, for example dateutil, and you would have more functions here, then you're completely fine with a normal object, since this is not a type of instance that you would get from a JSON parsing library, for example. But the moment you actually have classes that actually relate to some kind of data or a specific piece of information, like just the class name itself can be a piece of information, as we will see in a moment with another type of class, then a data class, the data object makes more sense. But I will come back to this example in a moment. Before we come back to that, let's get to another type of class, and those are so-called enum classes. Enum stands for enumeration, so we have an enumeration of multiple values. So if you want to represent a set of related options where you can choose one of them in a more human-readable form, then enum classes are for you. For example, a practical use case would be HTTP status codes. So a backend server could respond with specific types of status codes, like, hey, that request was okay, that request was not found, so you made a request to some kind of URL that didn't exist. This type of request maybe lacks some important parameters. And if you now want to kind of pass this result around, so was the response actually okay? Was it a bad request? Was it not found? Then instead of just passing around these rather hard to understand response codes like 401, 404, 200, you could model this as an actual more readable representation in enum class. For example, HTTP status. And then you say, I have okay, I have not found, and you have maybe bad request. So the convention for enum classes is, or for the values, is just all uppercase with underscores in between. And then when having this, we could go ahead and say, okay, we have the response, and that is HTTP status dot not found, for example. And then you could pass this around, which is especially helpful to also limit a specific amount of values to only valid values. So if you would pass around an integer code, so the actual status code, then this would also allow to pass values like 1000, which is definitely not a valid HTTP status code. But with enum classes, you can say, hey, I actually have a limited set of related status in this case. And by having this limited set, we can only choose based on this limited set. The interesting thing about enum classes is that they can have a constructor. So we can give this a constructor like the actual code or the message, for example. And then each of these options here needs this constructor or needs to invoke it right away. So in this case, it would be 200 okay. The completion is already working fine. Here it would be 400 bad request. And here it would be 404 not found. So that's a very important concept to understand about enum classes, because the values of an enum class are effectively just constants in our code. So that means there's just a single value for an OK status code. And that means the code here and the message for this particular status will never change, which is exactly what we need in this case, because this concept of HTTP calls will definitely not change. But what we can also do for enum classes, what many people don't know, is we can give these actual functions. So we can cut this last value off here with a semicolon, and then we actually go ahead and say we have a function, for example, to response string that returns a string and then maybe prints or just returns the actual error together with the code, together with the message. And if we then go ahead, go up here and actually say, okay, print our response dot to response string, and we run this, then we will see error 44 not found. So took the not found error and then took a look at, okay, what's the code of this not found error? It's the 44. And what's the message? It's not found. And then concatenated these two to make up such a string. Another useful thing of enum classes that no other type of class actually offers in that way is that that all options are being known in compile time. So that means we can easily iterate over these options. So we could say we have our HTTP status, and every enum class by default has this entries value, which is an enum entries, and we can use this to iterate over that with for each, and then print it.name, for example. And if we execute this, we will see all options from this enum class being printed in the console. This is sometimes super useful if you maybe have a dropdown in an Android app that is made of a very specific, of a limited set of options, which is pretty much always the case for a dropdown. Then I would always use an enum class for that and simply iterate over this dropdown over all of these enum values to show these in the dropdown, because then by default, the moment you add another option, you would just go to this enum class, add another option, another value here, and it would automatically be considered when looping over, so the dropdown is automatically being extended with that option. Okay, let's put a check to enum classes for a moment and get to a type of class that is often confused with enum classes, or a class that is very similar to enum classes but has a crucial difference, and those are so-called sealed classes. So we might have a sealed class that is also used to just bundle related values, and especially a limited set of values. So for example, we might want to have something like a network result that can hold a certain value. So if a network call was successful, we might want to return the actual data and wrap this in such a network result value. But a network call could also be a failure, and in that case, we don't have any data to pass, but rather something like an error message. So again, you see, we have some options that are all being network results in some sense. So why not use an enum class for that? Well, let's take a look at how the implementation of the sealed class would look like, and then it will make some sense why we're not choosing an enum class for that. So we would simply take the sealed class, and typically inside here, we could then extend the sealed class, so inherit from it, for given child classes that we define in here. For example, a data class that represents success, where we pass in the data. Let's just have a simple scenario where the data would just be a string, but you could also make this generic to work with any type of data, of course. And this would now inherit from network result. And the same thing we could do for error messages. In this case, we wouldn't have any data to attach here, but rather something like a throwable, for example, so something that went wrong, an exception. And the special thing about sealed classes is that all those options, all those child classes, have to be in the same module as that sealed class. So if you would, for example, get this network result sealed class from a library, then that library would be in its own module. That means you would not be able to extend this sealed class in your own code. So you could not define your own type of network result that exceeds these two purposes the library would have already defined. But still, what's the difference to such an enum class? Because both of these types of classes, as you've seen, are used to just define a limited set of options. These here HTTP codes, and these here different types of network results. Well, the crucial difference between these two classes is that having a sealed class allows you to have individual instances of these child classes, of these options of a network result in this case. While an enum class, as I said, really just makes up constants. So for an enum class, when having a constructor, these values have to be known at compile time already. So you have to put these variables, you have to invoke the constructor of these functions already in your code. And if all OK HTTP statuses actually have the same code and the same message, then an enum class is what you want. But here for network results, this is different, because we might have two independent network calls in our program, where one was successful and held data 1, And another one may also be successful, but held a different type of data. So here we can now create individual instances of the success, where we say, hey, that's the success message for our call 1, and that is the different type of data that call 2 hold. So up here, if we actually create an instance for this, we could say val result is equal to network result dot success, and this would be data A, and we could have another result that would be data B. So this time we have 2 individual independent results that hold different data, but with the same concept of having a successful call. And that's something that's not possible with Enum classes because they are really just constants. And from a constant, we can't have individual instances. And CL classes are now also those types of classes where I mentioned that data objects definitely have a use case. So here, for example, we could add a data object, which is something like empty. So you maybe got a response, but there was no data contained in it, for example. Then we could say we have a data object empty, which is a child as well from this network result. But since we don't need any extra information, since for an empty response there is neither a piece of data we can attach nor an actual throwable, so we don't have a constructor at all. And whenever you need a class for something that does not have a constructor and does not need internal state, then make it an object. And now assuming you actually want to log all types of network results, then it's of course quite helpful if you have this data object here, and it would normally just print, hey, that was an empty result without any difficult to understand memory address. And what's also a thing, as I mentioned, JSON parsing libraries, you can also parse actual sealed classes from with Kotlin actualization, for example, and this will work properly without bugs by just making all these instances data objects if they don't need a specific constructor. Sealed classes are of course just a normal class as well, so they can have a constructor. And if you need all these children here to actually have a certain piece of value or implement or pass a certain piece of value, you could just have a constructor here in the sealed class. So you could say, I don't know, they all need to implement a counter. Doesn't make sense in this case, but then here in all cases, you would need to pass this counter when you actually create an instance of this network result. But let's revert this. This doesn't make any sense. If you have a sealed class and it does not need a constructor, you can in fact make this a sealed interface because that's the behavior of interfaces, that they don't have a constructor. So in this case, a sealed interface would probably make more sense. Then you also wouldn't invoke the constructors here. But since this video is about classes, let's leave this as sealed class. Coming to the next type of class, which is again similar to sealed classes, but has one crucial difference, and those are so-called abstract classes. An abstract class could, for example, be a sensor. Let's take the Android example again. An Android device has certain sensors, and every sensor might have a name. So we might have an abstract val for the name. Every sensor might have an abstract function, maybe, that delivers sensor values. For example, the motion sensor that delivers value for the current acceleration of the device. So we could have a function to start listening, which will give us a callback when a new value is ready. I don't know, let's just say all values are in float format, and then don't return anything. What does that now mean? Well, abstract classes are useful if you want to still define shared behavior for child classes. So these are only relevant if you actually want to establish an inheritance hierarchy. So if you want to define shared behavior, that we say we have a sensor, every type of sensor definitely has a name, and every type of sensor definitely delivers some type of data. But you also want to say that there is no scenario where we would just have a sensor. If we have sensors, then we always have specific sensors. So we might have a motion sensor, an acceleration sensor rather. We might have a heart rate sensor. We might have a gyro sensor, but we don't just have a sensor. Still, all these child sensors, a gyro sensor, acceleration, heart rate, all those sensors do have a name and do have a start listening function that delivers the sensor values. So with an abstract class, we can define this behavior here on an abstract level and let then other child classes that could not just be normal classes implement this behavior. So a heart rate sensor, for example, that would then inherit from this parent sensor class. And now, since we made it abstract, we are forced to actually implement this behavior we define in this abstract class. So we can hit Command I, for example, override this, and then define this to say, hey, we have a name for the heart rate sensor, and we have a specific implementation for how sensor values are being listened to and how we forward them to this callback. So whenever you want to define shared behavior for child classes, but also want to say that there is no purpose of creating an instance of the parent class itself, then use an abstract class, because if we go up here, you will notice that if we try to just create a normal sensor and invoke the constructor of the normal sensor class, then it complains because you cannot create an instance of an abstract class. Because by design, we can't do that. But we can very well define an instance of this heart rate sensor, which is a child of this abstract class, because this is now something specific, while just a sensor isn't. However, sometimes you also have this behavior that you want a class to be inheritable, which normal classes aren't. So, by the way, if we try to inherit from the session storage, for example, this doesn't work. It says, okay, this type is final, so by default classes are final. That means we can't inherit from these. What now happens if you have a class that you want other classes to inherit from? You want to have that possibility, but you also want to be able to create instances of this class itself. So we pretty much have a sensor class, for example, and we say, okay, it's actually valid to create an instance of a sensor, but we still want to be able to inherit from sensors. In these cases, we can work with so-called open classes. So, for example, we could make this heart rate sensor class an open class, and this means it's open to be extended, but we can also just create DOM instances of this class. So we could have some kind of custom heart rate sensor, I don't know, and this would now inherit from our heart rate sensor. And this would now make perfect sense. Here we're not forced to override these values anymore, since they were already overridden in the parent class, but we could optionally override this. So we could say the name for this custom heart rate sensor is now our custom heart rate tracker. I don't know. And the same concept also applies to functions. So you could make this function here open, for example. That means you would need to give it a default implementation, which would be used if it's not explicitly overridden, but then it's just optional to override it, but you need to provide a default implementation. If you don't want to provide a default implementation, you need to make it an abstract function, and then you're forced to override it in one of the child classes. And when we're already at the topic of inheritance, let's get to kind of a special type of class. I don't know if that's a specific new type of class or a separate type of class, but it's still something that I think is worth mentioning, and those are so-called anonymous classes. Because we cannot only make normal classes or open classes or abstract classes inherit from other classes, but we can also make objects inherit from other classes. So here, our date tutor, if we would want that, could inherit from a sensor. And then we could also just define the name and the start listening function here in this object, but inheritance works exactly the same with objects as with normal classes. And sometimes you just want to kind of create an instance of something like an abstract class or a normal class or of an interface directly in your code without actually having to define your own class blueprint like here. In these cases, you could work with anonymous classes. They're called anonymous because they don't have a name. So we could inline a class kind of here, where we say our special sensor, for example, would be equal to an object without giving it a name, and this anonymous object would then inherit from sensor. And then we could say, we give this a body, override the name here, like special sensor, start listening function would have some kind of implementation. So here we effectively also have a class, but it's an anonymous one. It's one that we can dynamically create in our code without having to define such a class blueprint here on our own. Two more classes that I want to cover. Let's scroll down, and these are a bit easier to understand. The first one are so-called value classes. So we can have a value class, and a value class simply has the purpose to hold a single primitive value. So sometimes we work with primitive values in our code that need certain extra rules. Think of an email address, for example. An email address in your code is really nothing else than a string. But not every string is a valid email. And such things we could define with value classes. So we might have an email class where we just have the actual email in the constructor. So we just want to have a single value here. And these classes might also have a body. You will see that the value keyword is underlined because for these types of classes, we need to add this JVM inline annotation. But in here, we could then define something like an init function that actually checks if that email is a valid one. For example, if the email does not contain the @ symbol, that's a super simple and not correct validation. But in that case, we could throw something like an illegal argument exception. You've seen it here with invalid email. Obviously, real email validation requires pattern matching. But I think you get the idea, because that way we could still implement email-specific behavior, but the email itself is really just a primitive or a string. But the thing is that the main difference between this and having a data class email with that email. That's something we could, of course, also do. But the difference is that when our code is actually compiled, an instance of this email class we could create up here. So we could say we have an email, and that is just some kind of email. So just a normal class instance. But under the hood, when the code is compiled, there won't be an extra instance of this class being allocated, but it will really just be treated as if it was a normal string under the hood. So this is just more memory efficient. And whenever you have these kinds of cases where you just need a single class in a single piece of data that is based on some kind of more high-level concept like what an email address is, or that needs extra validation, then make use of a value class. So if it's simply used to hold a value, that's where the name comes from. This JVM inline annotation is used to just inline this class. So that means it won't be treated as a separate class, but really just as the primitive or this string under the hood when being compiled. And the last type of classes we want to cover here are so-called annotation classes. An annotation class is really just an annotation, just something we can use to mark another piece of code as something. So on Android, for example, the most popular type of annotation is the deprecated annotation. So that means, hey, we have a function maybe in our library, in our source code, that still exists, so developers can use it. But we plan to maybe remove it in the future because it doesn't use any up-to-date technologies anymore. And that way you can mark a specific function as being deprecated to show developers, hey, you can still use this, but prepare that in some kind of future release, we will remove this function so developers could already prepare. Annotation classes are really nothing functional, but really just to give developers a hint on how something behaves. Or we can use these as markers, for example, for compile time code generation tools. So a very popular example on the Android side is the Dagger Hill library, which heavily works with annotations, where a library just needs you as the developer to mark certain functions, certain classes as being the type of classes the library is looking for. And then the library can take over and say, okay, for these classes, actually generate and prepare the code that you will need for this app. For annotation classes, we typically add annotations as well to define which specific type of concept these apply to. So to a class, function, to a field, and these kinds of things. So we can define this target and then say, okay, we can actually apply this custom annotation to classes. We might want to apply this to a constructor, for example. And then let's actually call this custom deprecated because I think there is already such an annotation. And then we could add this annotation here, just like the JVM inline one, to a class by saying custom deprecated. That would work. We could add this to a constructor. So we could say custom deprecated constructor. That would work. But the moment we try to add this to something invalid, like this name variable here, then it would complain, hey, that's not a valid target of this annotation. So we would either need to define to also consider field variables here, or it would just not be a correct use case for this particular annotation. And I actually told you that that was the last class, but just another one came to my mind, and that's also not a difficult one to understand. But for that, we need to scroll up a little bit, and those are so-called inner classes. An inner class, as the name says, is an inner class, so a class inside of another class. By default, we can also do this without making a class an inner class. So here in our session storage class, we could, for example, go ahead and say, we have some kind of, I don't know, file helper, for example, that is able to actually create a file if not exists. I don't know, something like that. By default, if we have such a class being nested inside of another class, we call these nested classes. If we then also add the inner keyword, we make it an inner class. An inner class has special behavior because it can only be defined inside of another class. So having this file helper here would not work because it's not included in another class. But if we make this an inner class, what this effectively does is this class will have context on the outer class. So that means here we would have full access to the actual variables of this class, to this file, which would be necessary in this case in order to check if the file does not exist. In that case, create new file. The AI agent suggests that already. That only works with inner classes to have a context on the outer class. If it's just a normal nested class, you can see it doesn't know this file instance because the code does not see any relation between this class and the outer class. If you want to use your Kotlin skills in order to build some real well-structured Android projects, then as I said down below, winter sale is going on until Monday, 25% discount on all courses and on all the already discounted course bundles. So if you've been thinking about getting one of these for a while, now is the best chance for quite a while. Thanks for watching. I will see you back in the next video. Have an amazing rest of your week. Bye bye.